Good morning. I welcome you all for a session on functions in C. Throughout this chapter, we would have a brief discussion on introduction towards functions, the need for modular programming, the different math library functions we do have in C, function definitions, function prototypes, header files, calling functions, and in calling functions we would have two different things, one call by value, the other call by reference, and we would have a couple of examples which would be followed by a special kind of functions what we do call as recursive functions. Now moving on towards the various aspects of modular programming. What is modular programming? If it were a big loaf of bread, it will be hard for us to take it up as such. So the better way to take up a big loaf of bread is to cut it into slices and have loaf by loaf or piece by piece instead of having it as a loaf by loaf. Now what is this technically sounding as? This is known as divide and conquer. What is divide and conquer? Construct a program from smaller pieces or smaller components. These smaller pieces are called as modules. Each piece is more manageable than the original proposition of the entire problem. That is, as simple as you make the problem, it becomes easier to be solved. And if we take some care in such a way that every specific part of it solves a particular functionality, then it becomes even more easier, so that the entire complex one becomes more simple. What is the main advantage that I gain if I make a complex problem to look simple? When it becomes simple, it becomes easier to maintain. Because in a software industry, 70% of the money is spent on maintenance. So the easier the maintenance, the more efficient is the software. That is why we try to cut it down into different modules. Now moving on to functions. What are functions? Functions are modules in C. These programs combine different user-defined functions with library functions. C standard library has a wide variety of functions. What are function calls? I have a function declared, I have it defined, but at the stage of a need, I would like to have that function called. That is, I try to invoke functions which I do call as invoking functions or function calls. So what should this contain? Every function or a function call should have a proper function name with valid arguments. A function performs operations or manipulations. A function, after having all that manipulations done, returns us some value. How can I analyze a function call with a normal day happening? Take something like this. A boss asks his worker to complete a particular task. What happens then? The worker gets information, does a task and returns a result. The information hiding, the boss does not know any detail about what has happened, but he has come to know that something has happened. So this is an real-time analogy which makes us to understand functions in a great way. Then we go for math library functions. The various mathematical library functions we do have in C programming. As I told you before, in the inclusion section of your program, you can very well include a number of header files. One out of those happens to be a math.h library function. This particular function consists of several mathematical predefined functions which can be used at any point in time, provided they are included in your inclusion section. What is the format for calling these functions? These functions are getting defined inside a header file, and we need to know how to invoke those already built in inclusion section files. Now take it for example, I need to provide the function name, along with parameters. What is the significance of this? There is someone walking along the road. I want to have a conversation with him. When will the person walking before me turn back to me? I should call him by his name, and if there are duplicates of those names, I should call him by his exact initial. Only then he tries to respond back to me. That is why whenever we try to call a function, we call it by its name as well as passing the correct parameters that are being defined on the function declaration. If there are multiple arguments, use a comma to separate the list. Say for example, a function name add takes in 2 parameters for example, then the first parameter can be separated from the second parameter by having a comma between it. For example, a printf statement can have a comma after a string, which is a mandate, and it can have a variable on the other side. This calls a function sqrt, which returns the square root of an argument. All math functions have return data type as double. Arguments may be constants, may be variables, or it may be expressions. These arguments what I have here are termed to be either constants, variables, or expressions. Now let us move on towards the core programming about functions. What are functions? Functions modularize a program. All variables declared inside functions are local variables. Imagine whenever I try to declare a variable within a function, then the scope of the variable is tied only within that function and it happens to be a local variable. It is known only when function is defined. What are parameters? These parameters are those which communicate information between functions. These are also known as local variables. Whatever I have here within a function are termed to be local variables. Now every function needs to have a return type, then a function name, then it should have a parameter list. It should open up with a left curly brace. It should end up with a right curly brace. This is what we do call as a function definition. What is this return type? I have created a function. Someone has called that function. In what way would the function respond back? Is it going to simply keep mum after doing something, or is it going to return you something else? If it were not going to return anything, then the return type eventually happens to be void. And if this program or this function tries to return some value, then the nature of the value that it returns takes the type of your return type. Then function name follows the same way as we frame rules for an identifier naming. This parameter list depends upon the number of parameters we wish to supply for this entire function. Some functions may not need parameters at all. In those cases, this space may be left blank. And then every function definition starts with a left curly brace and ends up with a right curly brace. If you are simply interested in declaring a function rather than defining a function, the better way to do is need not have a left or right curly brace. You simply end it up with a semicolon, which means that you have simply declared a function as like any other variable. Fine. I have a function. What is the benefit of having a function? Here you can make use of divide and conquer, which manages a program development. As I say, it is breaking into pieces. It can also be said that this software can be reused at any point in time. What is reusability? It is the use of existing functions as building blocks for new programs. And at last, it also achieves a level of abstraction, which usually means hiding of internal details. So these are the benefits that I get out of a function. Now, how to have function definitions? The function definition starts with the return type value of a function, followed by a function name, followed by a parameter list. Then, as I said, it is a definition. You won't have semicolon here. Rather, you will open the function definition with a left curly brace. It would have a sequence of statements which need to be computed within this function. Then it ends up with a right curly brace. What is function name? Function name is any valid identifier. Please follow the rules that we have had for naming an identifier. I hope we could have had it in the very first chapter. Then, what is return value type or return type? This is a data type of the result. Whenever I have no particular thing to be returned, I make this as void. Void indicates that the function returns nothing. At last, we have a parameter list. It is a comma separated list that declares parameters. A type must be listed explicitly for each parameter unless the parameter is of type integer. I repeat again, the type must be listed explicitly until and unless if it were of type integer. So, these are a few rules that we do have in function definitions. Then let us move on towards the function definition format. Now, you have a function, you have its return type, you have the function name, you have a parameter list. How about the declarations and statements? The declaration and statements is termed to be the function body. What all can I have within this function body? You can have variables which can be declared again within these functions. Functions cannot be defined inside other functions. Unlike ifs and for loops, you cannot have functions within another function. Then how control gets returned back? If nothing returned, it will simply return, or until it reaches the right brace, it keeps moving within the function, and once it reaches your right brace, the function or the control gets returned. Then if something gets returned, what will happen? That return expression will be thrown out. This is how the functions are getting defined. Then let us have a simple program that has a function prototype, then it inputs some values, then it has a function call, and at last you would also have a function definition. This is the typical program which shows all these features. If you look at this program closely, it includes an stdio.h header file, then it opens up with a main function. Main function is a typical example of a function where this main function is unique in every program. There will be only one main function in any C program, and it is a mandate one. You cannot have nothing less than 1 or greater than 1, but you would exactly have one main function. This points to be the entry point of any program of C. Now, what do I do here? Here I declare 3 integer variables A, B and C. I have a few printing statements, that is, I want the user to enter 3 integers, then I try to obtain them in the variables A, B and C respectively. Then I try to find out the maximum, where maximum is the function that has been declared and defined within my program. Now let us move on towards the function called the maximum and its definition. It is a function maximum which takes in as 3 parameters. Then it initializes a variable max as x. If y were greater than x and z, then you term y is the greatest one, and if y were to be greater than maximum but less than z, you term z to be the maximum, else you term x to be the maximum. So this is the function definition that I give for this entire function. But this function returns me out a value which is of type integer. That is why its return type is mentioned as int. So this is a typical C program that has taken in 3 variables, then calculates the maximum within a function called maximum, and then tries to return out the value which was found to be the maximum amongst the 3 values that we have supplied. So this is a program that explains you how functions are getting defined. Now moving on towards function prototypes. What are prototypes? As we all do know, in normal literature, prototype defines as something like a model. So what is a function prototype? A function prototype is a function name. It tells us about the parameters as what the functions take in. It gives us the return type of data. The return type default is termed to be integer. It is used to validate functions. Prototypes only needed if function definition comes after the use in program. You please note this point. Prototypes are only needed if function definition comes after use in the program. That is why I said whenever you are just going to have it declared, you end it up with a semicolon, which is termed as a prototype. This is a prototype where the definition comes after the usage. Then This function with an example for a prototype is given as int max, where I take in 3 parameters and I ended up with a semicolon, which means that it takes in 3 ints and it returns a simple integer. What are the promotion rules and conversion? Converting to lower types can lead to errors. So, try to avoid converting into lower ones. Then we shall have a brief look at the various header files. Header files do also contain a number of function prototypes for library functions. Once you can go across all these header files, and whenever you are in need of such functions which are defined inside these header files, you can very well make use of them. The simple thing is you want to include them into your inclusion section. This is what we do have in header files. Now, I have a function prototype. I have defined a function. Now, I want to make use of this function. What is that I have to do? I will have to call the function in order to make use of it. How do I call functions? How do I invoke functions? Invoking of function happens in 2 different ways. Number 1, call by value, and number 2, call by reference. What is call by value? The copy of the argument itself is passed to the function. Changes in function do not affect the original thing. Then use when function does not need to modify argument. It avoids accidental changes. These are the benefits that we get out of call by value. I repeat again, we pass the copy of the argument itself towards the function. Number 2, changes in the function do not affect the originals. Use this function only if there is no need to modify the argument. It avoids accidental changes. So, these are things that we have as benefits out of call by value. What is call by reference then? It passes the original argument. Note down the difference. In case of call by value, it passes a copy of the argument, whereas the call by reference passes the original argument by itself. Then the changes in function affect the original, because the thing that we have passed in is the original argument. Only used within trusted functions. If you have a very good trust in a function, use this. Otherwise, go for call by value, which does not disturb the original value. Then we focus on call by value. To start with, we focus on call by value, and as and when need arises, we would move in for call by reference. What is there with call by value? That is, I have a function, I pass it by passing a copy of the actual arguments. That is what we do have in a normal call by value.